All right. So we continue. So let's do a couple more examples and then we're gonna finish off on friction. So here in front of us, we can see a box. The box is inclined at a gradient here. So you've got the 30 degrees angle. This box is very heavy. It's 50 kilogram. There's a guy trying to give a push in order to stop the box from sliding down the plane. So this is very important, sliding down the plane. The box wants to go down. You are trying to stop it. So what is the force required in order for you to stop it from sliding down? Definitely there is something called static friction, which is 0.25, which is helping it. So 0.25 friction is over here. The box is going down, so you've got friction forces stopping it. So one thing for sure, I don't want you guys to draw mg like this. So don't draw mg like that. Mg, don't draw like this. You cannot draw like this. Why? Because planet Earth, the gravitational pull is towards the center of the Earth, wherever you are on the planet Earth. So if you look at this clearly, it has to go down. So go down. So make sure you draw your mg going down. Okay? Alright, so let's start. Number one, let's draw a proper free body diagram. Two information you have here, 50 kilogram and mu s is 0.25. P is over here. Definitely you have P. You have mg going this way, going down. And then you have to remember, this box is trying to move this way. Since it's trying to move this way down, friction will make it hard for it to move. So mu s times normal, which is equivalent to friction static, is in this direction. So you've got how many forces? One friction, P from the hand, and mg going down. So pretty much that's it. So one thing for sure, in order to solve this, you have to resolve mg. Mg you have to bring forward, bring down. So if you bring mg down, it becomes like that. So you need to resolve it into two components, like so. This is mg. So if this is 30 degrees, this is also 30 degrees. So this will be mg sine theta, and this one will be mg cos theta. Okay, so many of you are not sure about this 30 degrees being there. So let's try to resolve this once and for all. We need to do some sketching. So this is your normal, this is your 30 degrees, this is definitely 30 degrees. If this is definitely 30 degrees, this is your mg, right? If this is 30, this is 60. If this is 60, this is definitely 30 degrees, which is here, okay? So you can based on this picture in order to resolve what is important. So in order to solve this, you can solve this by creating an axis like this. This is x, this is y. You can solve this, but this is going to make your life harder. It is smarter to solve this like this, like so. take the inclined surface as x and normal to that surface as y. So this is as if you are rotating your paper a bit. So it becomes like this. So in order to solve this, we have to do the same thing. Summation. So I'm going to remove all this one. So this is okay. You understand already. You have written down. Let's solve. Summation fx is equal to 0. So x positive is going that way. Okay. So what do you have right here? So you've got mu s times normal minus mg sine 30 degrees equals 0. Is this okay? mg sine 30 negative, correct. I don't see anything else. Aha, I'm missing a bit. I'm missing p. So you need to put p in your equation. You've got certain things missing. P is definitely... is this making it harder a bit? P is here, right? So P is like that. If this is 30, this is 60, this is also 30 degrees. Are we okay? So going that way is P cos theta. Going, should I change color? I need to change color, I think. No more red, blue probably. So this one is actually this force. So you have P cos theta, P cos theta, and also P sin theta. And of course this one is perpendicular like that. P cos theta, P sin theta. So these are the few things that I've missed out lah. Since my positive x-axis is like that, so I can just use P cos theta. So let's write down. So this one has to be plus P cos theta is equal to 0. Are we okay? Mu s times n minus mg sine 30 degrees plus P cos theta, and the theta is 30 degrees lah. 30 degrees. Okay, let's simplify. So you've got 0.25 n minus 50 kilo, 59.81, 0.5 plus 0.866 p equals 0. Simplify this equation, you're gonna get 0.25 n jumbo 0.866 p equals 50 times 9.81 times 0.5, 245.3. So bring it over here, it becomes a positive 245.3. So this becomes your equation number 1. Equation number 1. Equation number 1. Alright. So we are halfway there. We are almost done. Next will be summation of forces in the y direction equals 0. So this way is positive. Okay, so you've got to get used to this. This direction is y-axis. So in the y-axis, you've got, I'm missing a few things. I'm missing normal. Normal. So then we're okay. Normal force on the surface. So let's put everything back together. P, it will be a negative P sine 30 degrees. And then you've got negative mg cos 30 degrees. And then you've got plus n. What else am I missing? 1, 2, 3. That's it. That's it. So you've got negative 0.5 p minus 50 times 9.81 times sine cos 30, 0.866 plus n equals 0. So 50 times 9.81 times 0.866. This one becomes negative 424.8. Or to 4.8. Okay. Negative 0.5 p plus n equals 0. So your equation, you have to rearrange it a bit. So n to the depan. N minus 0.5 p equals 424.8. This will be your equation number 2. So make sure it is arranged properly. N in the front, N at the front. 0.866, blah blah blah. Okay. So now you can solve using your calculator. Still forgetting it, press mode and then press 5. And then choose 2 unknowns. I think number 1. So 2 unknowns. So it's going to require you, so mode and then choose equation and then 2 unknowns. So and then you have to plug in plug in the value properly. 0.25 or rather it's going to be asking you a few things, right? A, B, C. A, B, C. So this one is equal, I think. A will be 0.25. And then 0.866. C will be 245.3. This one, 1, negative 0.5, and 4 to 4.8. So you're going to solve it, you're going to get x, and you're going to get y. So 0.25, 0.866, 245.3, 1, negative, where is my negative sign? Negative 0.5, 4 to 4.8. So dapat jawapan X sama dengan 495 Newton. Y is 140 Newton. Okay, settle. So dapat jawapan. X refers to normal lah. Y refers to B. Right? Because N dekat depan. Okay, just use your calculator. Next, there's an answer for that lah. You can try that one also. This one, I don't think we need to do this one lah. It's the same thing. Only thing different is what is the minimum force required to push the crate up the plane. So now the crate is going up. So this is the move direction. Everything still remains the same. So if it's trying to be pushed up, you're gonna get friction on the opposite direction. Remember? Just now, friction is in this way. Yeah. Let's check it out. You are trying to move this way. Sama. Ini. It's trying to move that way. Friction goes the opposite direction. Betul lah, that's right. Yeah. This is the direction of friction. Opposite motion. So this one mu s times normal. So the whole equation becomes equal except for this one lah, this part. This one becomes negative perhaps. You can try this. Try doing this. Yeah, let's move on to different examples. Sometimes you're gonna see in your engineering examples things like wedges. So for example, I've got a huge pipe here. This huge pipe is being stopped by a wedge. So you've got force wedge in the motion. So you've got one normal force and then another normal force. You've got two frictional forces. So this is object number 1 and this one is object number 2. This one is an example on wedge. You can try it out. And one important thing, this is frictional forces on screws. So when you look at screws, it's practically a wedge. One thread of the screw is like a wedge. Same principle as a wedge. So this is one rotation, 360 degrees. So this is basically one rotation, 360 degrees rotation. So it's like one long wedge being opened up. It's like this. It's like dikupas, right? When you take it out. So in order to get the torsional moment M, you can use this formula. R is the radius. What is W? What is W? W is probably, I have to check back. You've got a lot of different things here. This one is another theta. Okay, this is theta. Torsional M. R is the radius. This one you have to check back the books how this is being derived. This is going to be a very long derivation formula. But the good thing is, let's check out the books. Torsional moment. Let's open up some books. Engineering mechanics. Hibbeler on friction. Okay. Friction. There's this thing on wedge. So when you're learning about wedge, okay, this is the wedge. How it is being derived? It's not so simple. W is the force vertical acting on the thread of axis. The force W is the vertical force acting on the thread or the axial force applied to the shaft. Okay, axial force, meaning it's some sort of like a clamping force. How it is being clamped. How about theta S? Theta is that one. Theta S. This is a very long derivation. I'm going to update the lecture notes later on and then you can read about this. But by right, if you are able to settle this by looking at formulas, you're pretty okay. So you've got theta S, W is 2000 Newton, R is 5 mm, theta S 14.04. Yeah, we're gonna do some exercises, then we're gonna be okay. Yeah, this is the clamping force W. What else that we don't understand? Theta S. Yeah, this is the formula. Theta S is the angle of static friction, which is tangent -1 F over N. Okay, this is the thing that we are missing out, which is called angle of static friction. Okay, let's paste this in the formula. Angle of static friction. Later on, you can look at the updated notes. Okay, let's move on and finish this off. So you've got downward screw motion, and then this is a important example. If you can do this example, you'll be able to do it. It's slightly harder. Other than that, you've got rolling resistance. When objects is rolling on a surface, like your wheel or tire wheels, there will be something called rolling resistance. And then this is an example of a rolling resistance. And apparently we're done. Okay, so this is additional knowledge for you guys. But rolling resistance is very important for you guys to know if you're going to see in automotive. You learn more on this on later subject, probably vehicle dynamics, chassis and vehicle dynamics. Okay, so that's all for friction.